Okay, today we're diving into the silent signals that basically power our modern world. Wireless tech. It's everywhere, right? Especially when you look at the lives of young people. But while our world has been changing at light speed, some new science is asking a really important question. How do all these constant signals actually interact with brains and bodies that are still developing? Let's get into it.
So let's just start with the single most important idea, the one thing you really need to get from all of this. A teenager's body is not just a smaller version of an adult. Not at all. It's going through this incredible, radical transformation, a period of such rapid development that it makes them uniquely sensitive to, well, everything in the world around.
And that world we live in, it is completely saturated with wireless technology. I mean, think about it. Our devices are tiny, they're super convenient, and they're all marketed as being perfectly safe. They're in our homes, our schools, our cars. I mean, they're literally everywhere. And this has become the constant backdrop of modern teenage life.
So what makes teens so different biologically? Well, for starters, their brain is in the middle of this massive, complex wiring project. At the exact same time, their hormonal systems, which control everything from how they grow to how they feel, are in total flux. And then there's the physical side. Their skulls are literally thinner than an adult's, which means more of that radiofrequency energy can be absorbed. And on top of all of that, they just have a much, much longer lifetime ahead of them for all this exposure to add up.
So this leads us to the big question, right? What happens when you take these uniquely developing bodies and you place them in a world filled with constant, low-level wireless signals? Signals from devices that are often worn for hours and hours a day, right next to the head and neck.
Now, just to be super clear, we're talking about something called non-ionizing radiation. This is not the kind of radiation you see in the movies that causes heat damage or burns tissue. No. Instead, what new research is looking at are the much more subtle biological interactions, like how these signals might interfere with the very delicate communication that's constantly happening between our cells.
And here, right here, is the real heart of the issue. The safety standards that govern every single wireless device we use, they were set by the FCC way back in 1996. Just take a second and think about the technology we had in 1996 versus what we have today. I mean, it was a completely different planet.
And this is so crucial. Those old limits were based on a really narrow set of ideas. They were basically designed to protect a fully grown adult man from short-term tissue heating. That's it. They never even considered the unique vulnerabilities of kids or teens. And they definitely didn't evaluate what long-term, low-level exposure might do to things like our hormones or even our gene expression.
So this is where modern science comes into the picture. We're going to look at two recent studies that give us some brand new clues that really challenge those decades-old assumptions about what's safe. What's cool is that these two studies give us two very different but complementary views. The first one is a super-controlled lab experiment looking at the developing brain. The second is a real-world study that looks at what happens to human tissue after years of daily exposure. Put them together, and you start to see a much bigger picture.
Okay, so clue number one comes from Yale University, where scientists use this really fascinating tool called cortical organoids. Now, these aren't actual brains. Think of them as tiny structures grown from human stem cells that mimic the absolute earliest stages of brain development. It's a pretty standard method scientists use to ethically study how all sorts of environmental factors, from air pollution to microplastics, affect human tissue.
And listen to this, because this is absolutely critical. The level of radiofrequency radiation they used in this Yale study was 4,000 times lower than what our current federal safety limits allow. Let that sink in. That's just a tiny fraction of the legal limit, an amount that regulators would normally consider completely negligible. So what do they find at these incredibly low levels? Well, the study is pretty powerful. The researchers saw changes in gene expression and in the structure of nerve cells, changes that are characteristic of what's sometimes seen in patients on the autism spectrum. Now, let me be absolutely clear here. This study does not, in any way, claim that wireless radiation causes autism. What it does show is that this very low-level exposure was enough to actually alter gene expression during a critical window of brain development.
All right, now for our second clue, and this one comes from the real world. This study looked at the link between daily Bluetooth headset use and the development of thyroid nodules. And this was not just some simple survey. These researchers used really advanced machine learning tools to dig through the data, reduce any bias, and really pinpoint what the most significant risk factors were.
And how good was their model? It was incredibly accurate. A score of 0.95 is, frankly, off the charts. It means their model was extremely effective at predicting who was at a higher risk, which gives us a ton of confidence in what they found.
So what was the key finding?
It wasn't about whether you owned a Bluetooth headset. It was about how long you used it every single day. Longer daily use was strongly, and I mean strongly, associated with a higher risk of developing thyroid nodules. And of course, the thyroid sits right there in the neck, exactly where that exposure is happening. Duration, it turns out, was the critical factor.
So, okay, let's zoom out for a second and connect these dots. When you put the hard lab science together with the real-world data, a much bigger, more complete picture starts to emerge about our total wireless environment.
And here's the real takeaway. It is not about any one single device. A teen's exposure isn't just from their earbuds. It's the earbuds plus the Wi-Fi at school, the smart meter on the side of their house, the phone in their pocket, and the 5G antennas down the street. It's the cumulative load on a developing body that really matters. It all adds up.
And this timeline, wow, it really just drives home the massive disconnect. The rules were set back in 1996. Then, in 2021, a federal court literally ordered the FCC to go back, review its guidelines, and explain how they protect children from today's technology. And as of today, nothing. Radio silence. That is a pretty significant regulatory gap.
So, what on earth does all of this mean for our daily lives? Well, the goal here is not to cause fear. Not at all. It's about empowering people with good information so they can make smart, simple choices. It's about precaution, not panic.
And you know, there are some very practical, very easy steps families can take. Encourage wired headphones when it makes sense. Pay attention to how long earbuds are in. You know, maybe not all day, every day. A big one, avoid sleeping with wireless devices right on or next to the body. And maybe the simplest rule of all, teach the idea that distance is your friend. A device held just a few inches away from you delivers way, way less exposure.
Look, this isn't about rejecting technology or banning it. It's just about using it mindfully. You know, we teach our kids about eating healthy and why they need to get enough sleep. This is just another piece of that same puzzle, learning how to support healthy development in a very modern world.
Which really leaves us all with one final question to think about. When you look at the new science on developing brains and bodies, and you look at the reality of our totally wireless world, our safety standards from a completely different technological era, are they really adequate for today? I think that's a question worth asking.